During what would become the most dramatic month in space history, an apocalyptic explosion of near-nuclear magnitude took effect in the Baikonur Cosmodrome in Kazakhstan, 2 weeks before the Apollo 11 landing on the Moon. The Soviet N1 L5 megabooster launched on July 3, 1969, and detonated moments later. The rocket was the Soviet counterpart to the US Saturn V, with the intention to enable crewed travel to the Moon and beyond. Fortunately, only its first stage, the most powerful ever built to that day, ignited, while the rocket crashed back down. Quote, "Today I saw without exaggeration the end of the world, and not in a nightmare, but while fully awake and standing right next to it," Lieutenant Colonel Semen Komarovsky would declare about the massive explosion. The N1 moon project was subsequently pushed back 2 years and cost millions in losses. But Soviet officials didn't measure the setbacks in terms of money, but in the precious time they had wasted to win the moon race. Clandestine missions. On July 5, 1969, only 2 weeks before the Eagle's landing, President Nixon received a presidential daily brief from intelligence officials. Quote, "Deployment of Soviet recovery ships indicated that the USSR would launch a rocket to the Moon and bring back samples of lunar soil before the scheduled launch of the Apollo 11 mission." The first indications of the Soviet attempt were the seismic sensors at the location in Baikonur, which the CIA coded as 𝗟𝗘𝗚𝗘𝗦. US intelligence would also be able to listen to countdowns and access telemetry data streams from Soviet missions. In the span of Nixon's presidency, 3 N1 rocket launches failed, and the United States seemed to take an unquestionable advantage over the Soviet Union in the space race. Nevertheless, technical and policy analyst Charles Vick suggested that, quote, "the race was far closer than publicly perceived, based on declassified intelligence all the way back before Sputnik." By then, US intelligence officials did not know that the July 3rd mission had actually been the second attempt to launch the N1. The first one had been 5 months before, and it went undetected. Catching up. The Kremlin watched closely as the Apollo 8 flew around the Moon, the Apollo 9 tested the Saturn V, and the Apollo 10 set the stage for a lunar landing. The Soviets knew they were behind in the moon race even before their first N1 attempt failed drastically when their 3L launch rocket blew up in February of 1969. The N1 3L was a super heavy lift launch vehicle whose objective was to deliver payloads beyond low Earth orbit and eventually land a person on the Moon. By June 3rd, 1 month before the second attempt, top space officials met in Podlipki, near Moscow. The head of the Experimental Design Bureau, Vasily Mishin, assured the attendees that they had learned their lessons from the previous launch disgrace and had protected the cord control system from interference. The N1 5L was chosen for a new launch, and Mishin was confident it could be sent on a mission around the Moon. Furthermore, Mishin guaranteed that the next 6L mission would launch a full lunar orbiting spacecraft and return safely to Earth, and attributed any setbacks to delays from subcontractors. Mishin's superiors did not believe he was being forthcoming about the many challenges involved. Boris 𝗟𝗘𝗏, chief of flight control system development, supported Mishin, but added that although a 1969 deadline to manufacture and deliver all systems was realistic, further testing would still be required. This board meeting even discussed future missions to Mars. Under warning that any downgrades to the current task should be reported, Mishin continued fantasizing about manned missions to Mars. Still, he did not get any serious attention from the officials. The project's final schedule would be submitted to the Kremlin after re-evaluation from Minister Sergei Afanasyev. Meanwhile, Mishin was allowed to continue his studies on Mars, provided that they didn't interfere with the ongoing 5L mission. Development. The N1 5L rocket would fly with only some of the recommended changes after the first launch attempt. Further upgrades were put aside, along with the 4L rocket. During a series of meetings held in 𝗟𝗘𝗚𝗘𝗏, Boris 𝗟𝗘𝗏 informed his superiors that his flight control team would not be able to prevent the cord network from issuing random commands in case of a similar fire to the 3L. Viktor Litvinov, head of the General Machine Building Ministry, advised 𝗟𝗏𝗏 not to mention that detail in their State Commission meeting the next day. 𝗟𝗏𝗏 complied and assured Litvinov that he would look into the matter. There was no more time for delays. Vladimir Barmin, the head of the launch infrastructure, later proposed developing a program to guide the rocket into the desert in case of miscarriage. He was worried that the expensive facilities could be severely damaged if an incident were to be replicated on the launch pad. Besides the addition of more reliable power generators and a re-evaluation of thermal insulation, further structural reinforcements were needed. This was likely prompted by the results from the first launch, in which an acceleration of 35 g was recorded to press on the ring around the propulsion system on the first stage when all 30 engines reached full thrust. Overall, 10,000 data transmission points were placed on the spacecraft, and the 5L would attempt a circumlunar flight. The State Commission finally met at the main assembly building in Site 112 on May 30th, and Vasily Machine presented all the improvements made on the 5L. The launch was set for July 3rd. An explosion. To ensure rendezvous with the moon, the 5L launch time was set at 11:18 p.m. Moscow time. Nighttime was chosen to simplify evacuation, as most workers would have already finished their shift. 2 rockets were raised simultaneously on top of 2 consecutive launch pads at Site 110. On the right pad, the N1, and on the left, a mock-up version for running autonomous and integrated tests. It was a rare sighting at first, but the mock-up was returned to the building before launch for security reasons. Pre-launch preparations went smoothly, though a heat wave affected the personnel. After completion of fueling, all safety pins marked with red ribbons were removed from the vehicle. At the end of the workday, thousands were evacuated around the potential explosion radius. Hundreds of cars and trucks took officers and engineers to safety, along with anything considered of value. A second evaluation occurred by nightfall, when most personnel were relocated to Site 115, the closest safe spot. Special protective trenches were dug out for the occasion. Despite the project's secrecy, many people remained at close range to witness the launch, including locals and personnel family members. Others watched from their rooftops. As the N1 5L lifted off from the launch pad, a bright light illuminated the area up to the control center 50 kilometers away. An announcer reported, quote, 5 seconds, flight normal. 10 seconds, flight normal. But suddenly many thrust indicators and the pressure in engines number 1 to 12 dropped to 0. Several pieces started to fall off from the rocket's tail as it froze for a moment while at 100 meters from the ground. The N1 was the first rocket to have a functional emergency escape system, so when it began to tilt to the side, the engines at the tip fired, conveying the top section to safety. Finally, the gigantic rocket collapsed on the launch pad. Shocked eyewitnesses stared at the enormous red and black mushroom cloud that covered the starry sky above. The area around Site 115 was vibrating and roaring with shockwaves, and the cheerful atmosphere at the Site 10 residential area suddenly succumbed to horror. A failed project. The lights were turned on even as the launch pad was in flames, and the evacuation process was efficient. Incredibly, no one was hurt. Only 15% of the rocket's propellant detonated, so what could have been a 400-ton detonation only reached 4.5 to 5 tons. Still, it was one of the most powerful artificial non-nuclear explosions in history. The damage caused by the explosion is believed to have cost about 350,000 rubles, but that might be an underestimation. Later investigations speculated about the failure of engine number 8, which exploded a quarter of a second before liftoff. The cord system cut off all the other 30 engines but one, the 18th, whose thrust accounted for the tilting of the entire rocket. Despite several black boxes that captured high-frequency engine parameters being recovered at the site, coming to a definite conclusion proved unachievable. The incident was finally attributed to a foreign particle interfering with the system. However simplistic, no further explanation could be validated. The Soviet bid in the race to send cosmonauts to the moon had failed, as it would on 2 further missions in 1971 and 1972. The 4 consecutive failures led to the cancellation of the entire N1 project by decree of the Central Committee of the Communist Party of the Soviet Union. On November 23, 1972, Nixon was given another presidential daily brief that stated, quote, "The Soviets launched their largest space booster, the J vehicle, this morning, but it failed early in flight. It was expected to send an unmanned spacecraft toward the moon with recovery either in the Indian Ocean or in the Soviet Union. Because of the continuing problems with the booster, the Soviets' first attempt at a manned lunar landing is not expected until the late 1970s. If you'd like to know more about the mission in which the Soviet Union finally got to the moon, don't miss our video. The Soviets also landed on the moon. Lunokhod 1, the first tire tracks in space. And make sure to subscribe to our channels for many more space adventures.